Hi guys, today we're discussing about SQL operators. So we have five parts in SQL operators. First is arithmetic, second is bitwise, third is comparison, fourth is compound, and last is logical. So what is an SQL operator? So an operator is a reserved word or a character that is used to query our database in a SQL expression. To query a database using operators, we use a where clause. Operators are necessary to define a condition in SQL as they act as a connector between two or more conditions. The operator manipulates the data and gives the result based on the operator's functionality. So let's proceed in arithmetic operators. So what is an arithmetic operators? Arithmetic operators in SQL are used to perform mathematical operations on numeric data types. These operators can be applied to columns containing numeric data in SQL queries to calculate new values. And these are the arithmetic operations. Here we have addition, subtract, multiply, division, and modulo. So, SQL arithmetic operators are also necessary to understand and helpful in analyzing the data testing process. So sometimes you might having a requirement to analyze the particular set of data using the arithmetic operators and see what is the outcome of the overall data that you got. So let's try the arithmetic operators. Let's try first addition. So addition is adds two values. Here, example is oh, thir- select 30 plus 20. Oh, sorry, 20 and semicolon. Don't forget the semicolon as always. Then gonna execute that. So the result will be 50 here, and the message is this. So that's very simple. Let's proceed to subtract. Let's let's proceed to subtract and 30 minus 20 and execute. So 10, the result is 10, 30 minus 20 equals to 10, and the message is same message. So let's try the subtract. That's very simple to understand. Let's proceed to subtract, semicolon again, and execute. So the result is 600. So if you're gonna multiply 30 times 20, the result will be 600. Let's proceed in divide. In divide, example is select 30 divide 10, then semicolon, then execute. So the result is 3. The divide is divides one value by another, so the result is 3 and same message. That's very simple to learn. And last is modulo. So the symbol in modulo is percent. Example here in modulo, select 17, then the symbol, and let's try 5, semicolon, then execute. So the result will be 3 and message, same message again and again. So modulo returns the remainder of division. So that's very simple. That's our tutorial in arithmetic operators. Let's proceed in SQL comparison operators. In comparison operators, we will learn about how to use them to form condition for filtering data. The SQL comparison operators allow you to test if two expressions are the same. Example in comparison. Example, let's try the equal to. Example, select ostrich from products. Example is all the products that have price 18. So we can execute that. So these all the products that have price 18. So that's it for equal to. Next one is greater than. So greater than 30, then semicolon. Example is if you want to see all the products that greater than 30, use this sign, the greater than, then execute. So these are all the price that they have from 31 up to 264. So that's it. So let's proceed in less than. So this is a syntax for less than. If you want to see all the price that less than 30, use this sign and execute. So these are all the products that they have from 29 to 3, here to 3. Then let's proceed for greater than equal to. Greater than 30 semicolon, then execute. So here greater than 30, we include the 30. Compare before in greater than that don't have equal. So here you can see all the price that starting from 30 up to 264. Then same in less than less than equal to 30 semicolon again, then execute. So these are all the price that they have starting 3 up to 30. We include the 30 here. So that's it. Let's proceed to not equal to. This is the syntax for not equal to. Example here, if we want to see all the price including except for 18, just the sign not equal to, then execute. We can see all the price here except for 18 here. So that's it for comparison.
Bitwise operators. What is bitwise operators? Bitwise operators perform operation on a binary representation of number. They compare corresponding bits and return a new value based on the operation. These are the types of bitwise. We have bitwise OR operators, bitwise AND operators, and lastly we have bitwise exclusive OR operators. Let us first bitwise OR operators. Select A integer value or B integer value from bitwise. The result is 235. This means at least one of the two numbers has 1 at each bit position where the result has 1. Next, we have bitwise AND operators. Select A integer value and B integer value from bitwise. The result is 10. This means that only the bits that are 1 in both A integer value and B integer value contribute to the result. And lastly, we have exclusive OR operators. Select A integer value pi B integer value from bitwise. The result is 225. Exclusive OR operator result in 1 only where the two numbers have different bits. SQL compounds operators are shorthand for common arithmetic operation. combining assessment and mathematical calculation in a single step. Here's the types of compound operators we have. Add equals, subtract equals, multiply equals, divide equals, modulo equals, bitwise and equals, bitwise exclusive or equals, and lastly we have bitwise or equals. Let us first add equals operator. Declare act x1 integer equals 27. Set act x1 plus equals 2. Select act x1 has added underscore. The addition operator adds to the current value of x1. After this operator, x1 becomes 31. The current value 31 is the output with the name added to. Next, we have subtract equals operators. Declare act x2 integer equals 27. A new variable x1 is set to 29. Set act x2 minus equals 2. Select act x2 has subtracted underscore 2. The result 27 is under the alias subtracted 2. Next, we have multiply equals operators. Declare act x3 integer equals 27. An integer variable x3 is initial to 29. Set act x3 times equals 2. Select act x3 as multiplied by 2. The result 58 is returned with the alias multiplied by 2. Division operators. Declare act x4 integer equals 27. A variable x4 is declared the set to 29. Set act x4 divided by equals 2. Select act x4 has divided by 2. The resulting value 14 is output with the alias divided by 2. Modulo operators, or we call modulo equals operators. Declare act x5 integer equals 27. An integer variable x5 is initial to 29. Set act x5 modulo equals 2. Select act x5 has modulo of 29 divided by 2. The result 1 is output under the alias modulo of 29 divided by 2. Bitwise and operators. Declare act x6 integer equals 9. The integer variable x6 is set to 9. Set equals 13. The AND operator perform a bitwise AND between 9 and 13. Select act x8 has bitwise AND. The value 9 is output with the alias bitwise AND. Bitwise exclusive OR operators. Declare act x9 integers equals 29. The variable x9 is initial to 29. Set act x9 exclusive OR equals 2. The resulting value 31 is output under the alias bitwise exclusive OR. Bitwise OR operators. Declare act x10 equals 29. An integer variable x10 declare with the value of 9. 29. Set act x10 bitwise OR equals 2. Select act x10 as bitwise OR equals. The final value 31 is output with the alias bitwise OR. Let's get started with our tutorial on logical operators. So the first one that we're going to check out is the logical OR operators. This selects all product ID values from the order details table where the quantity is equal to 10. This call return multiple products IDs. All operator will be behave like a recurrent operator and check if the product ID from the products table matches the single value returned by the subquery. If the match is found, it will return the product name, otherwise it will return an empty result. Next, end syntax. This part tells the database to select all columns from the customer table. It is specific that the data should be retrieved from the customer's table. The where clause gets the condition that must be met for the rows to be included in the result. If the conditions are true of some rows, the query will return all columns from the rows where. Next, we have any syntax. The subquery retrieves all products values from the products that where the price is greater than 50. These products at least of price that greater than 50. The subquery retrieves all price values from the products table where the price is greater than 50. The any operator requires the condition to be true for at least one value from subquery. Next, we have between. The database scans the products tables and check each row's price value. For each row, if the price is greater than or equal to 50 and less than or equal to 60, the rows included in the result. The price is less than 50 or greater than the 50, the rows is included from the result. The between operators includes the boundary bit values by default, meaning the range including both of starting value 50 and the ending value 60. Next, we have exist. This tells the database to retrieve the supplier name columns from the suppliers tables. The exist operators check only whether the subquery returns at least one row it does not equivalent the actual content of the row. Next, we have in syntax. This tells the database to retrieve all columns from the customer's table. The in operators check if the value in the column matches any value in the provided list. If the match is found, the rows is included. If not, the rows is excluded. Next, we have like syntax. The like operators is used to search for a specific pattern in the column's value. It is commonly used with wildcards. The like operators perform patterns matches based on the specific format. The wildcard allows any sequence of characters after the letter S, which makes it possible to match various cities' names starting with S. Next, we have not syntax. The not operator is used to negate a condition. It returns row where the condition is false. The in operator checks if the value is the column matches any value in the provided list. Or syntax operation. The or operator makes the query more flexible because only one condition needs to be true for the rows to be included in the result. If conditions are true, the rows is still included, but only one true condition is enough for a match. Lastly, we have sum syntax. The sum operator checks if the value in the outer query is greater than at least one value from the subquery. If no value in the outer query is greater than any value from the subquery to the row. And this is the last of our topic. Thank you for watching.